so much practical training into very short time. So at the undergraduate level of career, you did 5 times quicker, at least, or maybe even 10 times quicker than graduate students. And I cannot imagine what would you do when you come to the graduate school. So you have the greatest potential. So the subject today is a set of advanced topics, mostly for VASP software. Because when you do research, you may need to do something above the standard things. So there will be basically 2 chapters. One dealing with time aspect of the computations, and another aspect of unpaired speeds. So with this, a first speaker will give us the first introduction into how to go from the ground state, from 0 Kelvin, to elevated temperature. So Austin, floor is yours.
Thank you. Good morning, everybody. Today I'm going to be talking about running heating simulations in VASP. You guys like my IMG heat? Anyone seen it? Nero. Anyway, some background. So what is heat? Heat's basically a transfer of energy from one system to another. In molecular kinetic theory, it's transfer from one molecular ion group to another. Temperatures is a measure of the average kinetic energy, and then this theorem here is what we're learning with, that on a molecular level, heat's transferred by individual molecules kinetically banging up against a system and transferring heat. And below is, I think we learned that equation, and this is just showing the translational ways heat can be transferred. So in VASP, the steps, they start off with, first you have to have your files all set, the in-cars and postcards all downloaded. Then you copy that in-car, not the geometry optimization, but the heat one, and then you just modify the in-car by going into nano, and you change this number down to 50 or 100, and then these, which are your temperatures, you know, it says 300 here, but for our purposes, we put them up to 2000 Kelvin. And then just a little important part at the bottom, from moving to heating to molecular dynamics, what you need to do is take your COD from the heating file and then make that your postcard for the molecular dynamics job. This is just a screenshot of what it looked like in the nano file when you're inputting that. You got your temperatures right here that you change. I changed mine to 1500, and then you have your NSW, and I changed that down to 50. And then this is the molecule I was heating. It's got an aromatic ring with the amine group, and so I simulated the heat. I didn't get a graph for it, but you know, you guys got any questions?
Okay, let's thank